Greetings from TD4Pi IoT Hub. I'm Ibrahim Sheba, and we are here to present to you the DAQremon system, which simply means the data acquisition and remote monitoring system for water projects, agricultural silos, and energy resources like the gasoline, petroleum, etc. Statistics shows that 1 in every 3 Africans doesn't have access to clean and affordable water. And in line with the United Nations and the United Nations Sustainable Development Goal, water is a fundamental human right. Statistics further shows that about 400 million people in sub-Saharan Africa don't have access to clean and affordable water. Nigeria is one of the 46 countries in sub-Saharan Africa that have been plagued with the global water crisis. And of the 780 million people in the world not having clean and affordable water, 40% of these people belong to sub-Saharan Africa. In priority to Nigeria, with places like Sokoto and Katsina, 70 projects in 100 borehole projects have failed due to the unavailability of the system to provide preventive predictive analysis, data reports from this borehole project, and to give accurate data readings of water quality and microclimatic conditions of this environment. TD4Pi presents you with an indigenous technology which is IoT and AI embedded, incorporating these cutting-edge and emerging technologies into this to provide you with an affordable and clean, secure water in most remote rural areas in Africa, Nigeria, and sub-Saharan Africa as well. So it is equipped with environmental sensors like the gas sensor, the humidity sensor, the Dallas thermometer sensor, the ambient pressure sensor, the turbidity sensor, the pH sensor. All of these are a matrix of sensors to give you accurate and precise reading of the quality of water you drink, as well as communication protocols like the GPS, the radio module, the Bluetooth module, and the Wi-Fi module to help with the serial communication in conveying this data via an LTE for remote monitoring of these water projects. Because one of the biggest problems that we have is the unavailability of the companies and the government to look into the projects that have been sunk in several remote regions and also see the performance of these projects.
Okay, before I even explain what is inside, I want us to know that this product, although looking so neat like this, is not an imported product. It is an organic product, fully developed here at TD4Pi Hub. So the board you are seeing here, Unity board, is the main engine, the board that does the magic for us. So it's a robust system, data acquisition system. It's a robust data acquisition system, and without much ado, my colleague will be talking about the functionality of the Unity board as applied to this project.
Here with me is the Unity board, same copy of the board which is in the platform, an indigenous product produced here in Nigeria, which is in line with Pillar 8 and 5 of the National Digital Economy Strategy, which focuses on indigenous content. It is fully equipped with several sensors, which I'll point out to you here on the board, like the gas sensor, which is meant to get your gas readings, the Dallas thermometer, the humidity sensor. You also have the flow rate sensor. You also have the ambient pressure sensor and the luminous intensity sensor. We also have multiple communication protocols like the GSM GPRS module, the ESP module, the Bluetooth module, and the Iridium module. We also have the 7-segment display, which helps out with the counting and the binary sequence for the board. The power section of the board is fully equipped with the solar, which helps out with uninterrupted power supply due to power problems in Africa and most West African countries. And our power specialist will be doing a brief explanation on that.
Yeah, from the solar panel, voltage flows directly into the charge controller. And from the charge controller, it goes into a 12 volts battery here. So inside the system itself, we have a bulk converter which gives us 5 volts. We also have 12 volts coming out from the output of the charge controller. And the good thing about this very system is that it is vandal proof. If there's a sensor fixed here, if someone tries to remove the solar panel it gives us an alarm. The alarm which will be fitted in here.
Okay, this is how the sensor is fitted on the cover of the tank that we use to get the water level of the tank. And this is a sample of the flow rate meter, which I'm going to be showing you where it is fitted. Okay, this is a flow rate meter where it is fitted. Here is the tap. So every water that passes through here gives us the water utilization. This sensor here takes the water utilization of every water that passes through this tap. Okay, as you can see our tank right here, this is the tank we are using, that we are monitoring, and we'll be showing you the data to get data analysis of the tank here. This tank can represent your tank in your water project in a rural area, and it can also serve as a reservoir for a state water board project. And our system here monitors this tank using certain sensors such as the flow rate sensor and the ultrasonic sensor. This way we can get data telling us about the quality of the water and the water usage and the amount of water left in the tank. So here is our ultrasonic sensor. You can see it right here. It's used to tell us the amount of water left in the tank, and we also have the flow rate sensor here. This is a sample of one that's installed already in the tank that tells us the water utilization, with other sensors that also tell us get the microclimate of the area and the quality of water in this tank.